Hello everyone. So let us solve one question based on Kirchhoff's second rule, that is loop rule. Okay. So here one circuit is given. Okay, I'll read out the quantities which are given here. Okay. So EMF 1, E1 is 2 volt. Then there is an internal resistance of this, that is R1, 2 ohm. So you have to consider internal resistance also. Okay, E2 is 1 volt, R2 is 1 ohm, R3 is 3 ohm, E3 is 3 volt, and R4 is 1, E4 is 1. And the main biggest resistance is given here, R, which is 2 ohm. Okay, the main resistance. Now the current I is in this direction, I1 is in this direction, and I minus I1 is in this direction. Okay, now you can consider loop as you wish. Okay, so I am considering two loops, that is A B D A, and second loop B C D B. Okay, so let's start with loop A B D A. Okay, starting with the loop A B D A, we are moving against the direction of the current. First thing is E1, so positive to negative, this will be negative E1. Okay, moving forward, we are moving against, so this product will be positive I R1. Okay, again we are moving against the direction of the current, so this product will be positive R I minus I1. Okay, then again we are moving against the direction of the current, so I R2, and last thing is E2, negative to positive, it is positive. Okay, now let's put the values. So our E1 is 2, then R1 is 2 ohm, R is 2. We have to find currents I and I1, plus R2 is 1 I, and E2 is 1. Okay, now simplify this equation. This you have to multiply inside. Okay, so minus 2 plus 1 will get minus 1, then 2I plus 2I minus 2I1 plus 1I equal to 0. So 2, 2, 4, 4 plus 1, 5. So 5I minus 2I1, and this minus 1 I am taking that side, so it will be 1. This is our equation 1. Okay, now let's consider the another loop, that is B C D B. So considering loop B C D B. Okay, starting we are moving against the direction of the current, so R4, this will be positive, and this current is I1, so I1 R4. Then this E4 will be negative to positive, positive E4. Again E3, positive to negative, negative E3. Then we are moving forward in the against the direction of the current, so I1 R3 positive. Then we are moving forward. Now we are moving in the direction of the current. Okay, so we have to take negative R I minus I1. Okay, now putting values. So R4 is 1, so 1 I1, E4 is also 1, E3 is 3, I1 R3, R3 is 3, and R is 2, and I'll multiply this here only. So 2I, negative into negative, this will be positive 2I1. Okay, so considering I and this, okay, so starting with minus 2I, then I1 values are 1 plus 3, 4, 4 plus 2, 6 I1, and this will be 1 minus 3 minus 2. I'm taking it that side, so it will be positive 2. Okay, now these are our two equations which we have to solve. Okay, so let's use elimination method. Okay, so I'll multiply equation 1 by 2 and equation 2 by 5. Okay, or easiest method will be multiplying the equation 2 by 2. Okay, and this by 1, 2 by 3, so that our second term will be 6. Okay, so 5 3s are 15I minus 6I1 equal to 3. The second equation is minus 2I plus 6I1 equal to 2. Now we need not have to change this signs because already positive negative signs are there. Okay, so we can directly cancel this. So 15 minus 2, it will be 13I equal to 5. So I will be 5 upon 13. Okay, so our I is 5 upon 13 amp. Now you can put this I value in any of these equations, equation 1 or 2. Okay, so I'll substitute in equation, substituting in equation 1. So 5I minus 2I1 equal to 1. So 5 into 5 by 13, 2I1 equal to 1. So this will be 25 upon 13 to 1. So taking 25 upon 13 that side, so you will get 1 minus 25 upon 13. Okay, cross multiplying, you will get 13 minus 25 upon 13. Okay, so this will be negative 12 upon 13. Okay, this gets cancelled. This 2 you can take this side, so it will be I1 equal to 12 upon 13 into 2. So it gets cancelled, so we'll get final answer I1 equal to 6 upon 13 ampere. Okay, so these are our two values. I is 5 upon 13 and I1 is 6 upon 13. Okay, once you write down these equations correctly, okay, then further you have to just apply your mathematical skills. Okay, and then you will get the equations.